Hey everyone, and welcome. Today we're going to pull back the curtain and really get into the mind of a professional auto electrician. We're going to demystify what it really takes to fix modern cars, because let me tell you, it is a world that goes way beyond just swapping a few fuses. So I want you to think about this for a second. When something in your car just stops working, how does a great technician know exactly where the problem is? And that right there, that's the whole ballgame. It's what separates a frustrating afternoon of just guessing and replacing parts from a fast precision repair.
Right, and that's really the core of it. For a pro, a fault isn't just a broken thing, it's a series of clues. The whole process is about thinking systematically, about solving a puzzle, instead of just, throwing parts at a problem and crossing your fingers. All right, so let's get into how they do it. So, where does it all begin? Well, every single diagnosis starts right here, with the fundamental, totally unseen laws of electricity. You literally can't see voltage or current, but a pro, they understand the rules that make them tick.
Okay, so this might look like high school physics, but Ohm's law, V equals I times R, this is the language of electricity. It's not just some abstract theory, it's the foundation for every single measurement a technician makes. It's what tells you how voltage, current, and resistance are all supposed to play together in any circuit. And here's where that theory smacks right into reality. In a good circuit, you've got super low resistance, so the current just flows. But the moment you get high resistance, like, say, a bit of green crust from corrosion on a connector, Ohm's law guarantees that the current is gonna take a hit. And that is the direct cause of real problems, like a headlight that's gone dim or a power window motor that's painfully slow. So what happens when things get more complicated? With tons of different paths and parts. That's where these things, Kirchhoff's laws, come into play. You can think of them as the advanced roadmap that lets a technician figure out exactly how voltage gets used up and where the current splits off in a really complex system. Look, here's the bottom line. Understanding these rules, it's everything. It's how a pro can look at a diagram and predict exactly what they should be seeing on their multimeter. And because of that, they know in an instant when a number is wrong. It's literally the language they speak when they're diagnosing a car. And that number, that is not a typo. We're talking 40,000 volts. That's the kind of power you can find kicking around in a normal car's ignition system. And just understanding that that energy is there, well, that's the first step to working safely. Yeah, and when you're dealing with that kind of juice, it brings us straight to our next big idea. For a professional, safety isn't some checklist you just tick off. It's a core discipline. It's rule number one. It's about knowing the very specific, very high-stakes risks before you even touch the car. And we're not talking about vague, general safety tips here. The risks are super specific. We just saw the 40,000 volts in an ignition coil, but what about something as simple as a metal wetting ring? If that touches a battery terminal and ground, it can cause an explosive short circuit. We're talking severe burns and fire in a split second. This isn't some made-up scenario. It happens, and it's a huge, huge danger. So you can see why this stuff isn't just a friendly suggestion on a poster. Knowing these very real hazards is an absolute, non-negotiable requirement to be safe in a workshop today. It's all about having a healthy respect for the power you're working with. Okay, so you've got the rules down, you're being safe, so what's next? Well, before you can find out what's broken, you first have to know how the system is supposed to work in the first place. You need a map of the territory. A real pro, they know how all these different systems are wired up and how they're supposed to behave. They understand how a relay controls a wiper motor, how a window switch sends power, and which fuse protects which circuit. Basically, they have a crystal clear picture of what working correctly actually looks like. And why does that knowledge matter? Well, because when you run into a problem like this one, a power window that's dead, it could be any of those things. The motor, the switch, the fuse, a broken wire. Without that map, whether it's in your head or on a diagram, you're flying blind. You're just guessing. And this right here is the huge difference in approach. Knowing that circuit layout lets you build a logical, structured plan to find the fault. It saves time, it saves the customer a ton of money, and it stops you from falling into that trap of replacing parts that were perfectly fine to begin with. All right, now we get to the fun part, the actual detective work. Once you have the map and you know the rules, you can finally use your tools and your brain to hunt for those clues and track down the real root of the problem. But what's so important here is the order you do things in. You don't just grab your tools and start poking around. The first step is always to just look, listen, and see what the system is or isn't doing. Then you go to your map, the wiring diagram. It's only then, after you've done all that you start doing very specific tests to prove or disprove what you think is wrong. I love this quote from the source material because it is so true. The voltage drop test is the perfect example of a pro-level move. This is the test that finds those really sneaky, hidden issues, like a single corroded pin inside a big connector that's causing problems but not blowing the fuse. It's a test that literally pinpoints where energy is getting lost in the circuit. So finding the problem is half the battle. But fixing it right so it never happens again, well, that's the other half. And honestly, it's where the real craftsmanship comes in.
And when you look at how it's done, it's all about precision. Every one of these steps is non-negotiable. A good, solid crimp for mechanical strength, a clean solder joint so electricity can flow, and tough heat shrink tubing to seal it all up and protect it from moisture and vibration. And of course, the last thing you do is test it. You make sure it's strong and that it works perfectly.
I mean, just look at this comparison. It really tells the whole story, doesn't it? The amateur twist and tape job, yeah, it may work for a few hours, maybe a few days, but under the constant heat and vibration inside a car, it is guaranteed to fail. But the professional job, the one with the crimp, the solder, the insulation, that thing is built to outlast the car. So really, what it all boils down to is this. Being a pro is all about one thing: reliability. It's about doing the job right the first time, so you can be confident that the repair you made is as good as, and hey, maybe even a little better than, the original wiring from the factory. Which kind of leaves us with this final question to think about. When you combine that deep knowledge of electrical theory, that disciplined approach to safety, that logical, systematic diagnosis, and that high level of hands-on skill, is it just fixing a car? Or is it something more? Is it a true craft?